Hola physics. Okay, so today's screencast is on mirages, and just like the screencast that you created in class yesterday, talking about the refraction of sound, mirages are the result of the refraction of light. They are a real image, and they can be photographed. And let's talk about how and why they occur. Okay, so the speed of light is fixed in a vacuum. It's constant, but when it interacts with matter, it can be absorbed and then re-emitted, and that absorption and re-emission process takes time. So the speed of light is in air. Speed of light in air is about 0.03% less than a vacuum. Oops. And likewise, the speed of light in hot air is a little bit greater than the speed of light in cold air, because hot air has the particles are moving around faster, and hot air is actually less dense than cold air, so there are fewer molecules for waves of light to interact with. Okay, so on a hot day, the air kind of behaves like two different mediums. The air that is close to the ground is hot, and therefore it is fast, and the air that is above is cooler, and therefore it behaves like a medium that is slow. And you all know that if we have a boundary here, and we have a fast medium here and a slow medium here, and we have a ray of light that comes and hits the boundary at an angle, like so. Slow to fast, away. So instead of proceeding directly through with no change, the ray of light, or wave of anything really, is going to bend away from the normal here. So you can see that in this kind of hot and cool area, as light moves from the cool air up above to the hot air down below, it starts to bend as it's refracted as it moves from cool to hot. So kind of every instant it's moving through a boundary of a different medium as it moves from a cooler area to a hotter area. So it gets bent and projected back up into the air. And if there was no refraction, this light would have gone in this direction down here, but with refraction, it's bent up and hits you in the eye. You're standing just as a random eyeball right over here. So the way that you interpret this light is as if you were seeing it moving in a straight line. So you extrapolate from what you see here, and you project, or your brain interprets this as an image of a palm tree upside down, actually kind of in the dirt. So you can see an image here of a mirage. We have this, the exact same thing is happening here with this car. The light from this car is kind of coming down. It would have hit the ground, but instead it's refracted back up into your eye if you're standing right over here. We also see light from the sky that would have just hit the ground before, is also refracted as it approaches the hot road, and is projected. It bends back up towards your eye as well. So you see kind of this water-like image here, which is the refraction of the sky. So that is it for mirages. Mirages are caused by the difference of speed between air near the ground and air above. Ta-da!